Let's just discuss another case of the Doppler's effect of sound, in which both source of sound and the observer are moving. But in that case, source is moving towards leftward. Let us suppose this is our source. So source velocity is Vs, and this is our observer. Observer velocity is Vo. Both moving leftward. Both moving leftwards, and this is our sirens, and which sounded, and it's the sound goes toward the observer. So here both are moving. Both are moving. This is a moving source. So let us go one by one. In first case, when the sound source is moving away from the observer. So when the sound source moving away from the observer. So whenever the sound source moving away, whenever the distance between the observer and the source is increasing, the apparent frequency will decrease. So in that case, our moving source is moving away, our frequency will decrease. Now that frequency called apparent frequency. Let us suppose this apparent frequency will be FO is the original frequency as already said, and multiplications of V, since our source is moving. We are only considering here the source is moving away from the observers. Therefore, the source velocity comes. The terms of source velocity comes in the denominator. So since this is the apparent frequency should have to decrease. Therefore, in the denominator it comes out V plus Vs. This is V, the air velocity, sound velocity air, and Vs sound velocity, source velocity, and Vo is the observer velocity. So this is the equation number first, and FO, we already know that this is FO is the original frequency of the sound. Original frequency of the sound. And this is V, the air velocity, sound velocity in air. Sound velocity in air. So these are the some initial of the initial informations. Now in first case, now in the second case, we just suppose that our source is at rest, and only the observer is moving toward the source. In that case, when our observer moving toward the source, is distance between them will decrease, and the frequency will increase. So in that case, our numerator, since observer velocity comes in our numerator, the numerator should be greater than the denominator. Now in that case, when the observer is moving towards the source, moving toward the source, this will our equation first. Now the apparent frequency will be, suppose this is FA, apparent frequency will be FO1, not FO, here FO1 multiplications V plus observer velocity divided by air velocity. This will be our equation number 2. Now putting the value of F1 from here to here, so it has a value of, this is FO1. So we will get the required frequency heard by the observers, and when both are moving. So now putting the value of here, now our apparent frequency become, now of our apparent frequency, put the value of F1 from equation number first is here. So it will becomes V divided by V plus source, Vs is the source velocity, multiplications this term is V sound velocity in air plus Vo observer velocity Vo divided by sound velocity in air. So this term should be cancelled. Now final value become our apparent frequency now becomes Fa will be F4 times V plus observer velocity plus V plus source velocity. So this is our final frequency which is applied to this observer. Now let us do some numericals on these two formulas when both observer and source are moving. Now this is our problem in which both source and observer are moving. So here a policeman is chasing a thief from behind the vehicle. Let us suppose this is our policeman. Policeman and riding on a bike, and the thief also riding on a bike. He also moving. The policeman, this is our policeman, and this is the thief. Both are on their bike. So now it's a velocity of the thief is given. So velocity thief will be our observer and the policeman will be our because this the siren is on the bike of the policeman, so it will be a source. This will be our source and this will be our observer. Now it is already given that velocity of the thief, which is the velocity of the observer, which is 72 km per hour. The thief also riding on a bike moving with a speed of 72 km per hour. This is our 72 km per hour. If I if I multiply by 5 upon 18, it will convert into meter per second. And now 18 4 72 4 into 5 is 20. It will be 20 meter per second. It is the same way. If I convert 72, this is 72 km per hour, 72 km per hour, 72, and we know that in 1 kilometer there are 1000 meters, and in 1 hour it is 60 minutes, and 1 minute has 60 seconds. So if you simplify it, so we will get also 20 meter per second. So this is one value of observer. Now our source is also moving the same directions, and the policeman is behind the thief, and it is catching the thief. Velocity of the source, that is the velocity of the policeman, is 54 km per hour. So 54 km per hour, and it is the 54 km per hour, and this 54 km per hour should be converted into meter per second. You have to multiply by 5 upon 18. So it comes out 15 meter per second. So this is our value, 15 meter per second. So now here both are moving. Policemen have the tendency to catch the thief, so distance between them should decrease, and the thief has the tendency to move away from the policeman, from the sources. So the thieves will increase the distance between them. So the thief, it means that the observer has the tendency to decrease the frequency, and policemen have the tendency to increase the frequency. Now our formula becomes, we should have used this formula. Apparent frequency will be original frequency multiplied, since our observer is moving away from the source, so the numerator should be V minus Bu, and our source has the tendency to decrease the distance between them, then the denominator should be smaller one, so V minus Vs. This is our value. Now putting all the values, FO, here FO is already given, so sound frequency, our original sound frequency is, this is FO, sound frequency is given, which is FO 200 V minus, and our sound velocity in air is 330 meter per second, 330 minus observer velocity. Our observer velocity is 20 meter per second. 20 divided by V is 330 minus source velocity. Source velocity is our 50 meter per second, and this is the value. Now just the simplification, 200, 330 minus 20, 310 divided by 330 minus 15, it comes out 315. After simplification, we will get the value, and which will be 196.82. After calculating the value, 196.82 hertz. So you can see that the effect of the frequencies decreases from 200 to 196, because thief has a greater velocity than the source, because thief is moving away, and the policeman is catching the thieves. Policeman is going toward the source, no, toward the observers, and but the velocity of the policeman, velocity of the source is less than that of the moving away of the observer. That's why net effect will be the velocity of the observer, so which has the tendency to move away, so net frequency will decrease.